All right, I will start with the pull requests and people can going on. Let's see, not a whole lot again. This week we've got two new pull requests. One is from Adam, other Adam, core Adam, that is replacing my old PR to allow for separate Roxdb block caches on a per column family basis. The idea behind this is that by allowing for multiple Roxdb block caches, we can distinguish between the block cache that services onode column families and OMAP column families. And by doing this, we can avoid double caching onodes both in the Roxdb block cache and the BlueStore onode cache while preserving cache for OMAP entries. So my old PR was basically in place before we did the column family sharding and needed a refactor and rework. And since Adam had already done all of the column family work, I asked him if he would mind taking a look at it, and he's re-implemented it. So I think there's still a little bit of work to do there, but hopefully that will be fairly quick and we can get this in. It should result in basically much better cache behavior under the same memory envelope in the OSD. Let's see. The only other new PR was one for Ceph volume to retrieve device data concurrently. It was labeled with the performance tag. I don't actually know very much about this one, but presumably retrieving data concurrently would be a good idea. So I assume that that's faster. Otherwise, two updated PRs this week. There's a PR for allowing dynamic levels in Roxdb. This is probably a good idea, but could be kind of complicated for the user to set up properly. So this PR just basically makes it possible to do this. The way that our code was structured before, you really couldn't use that option in Roxdb. With this PR, now you have a way to actually try to do this. So we still don't know if it actually works well. We still don't know how a user would properly set this up, but at least this is the starting point. So I think it's a good change. It would just be really good if we could demonstrate a case where switching over to dynamic leveling or level sizing is really beneficial. Theoretically, it should be, but we should show it. The other updated PR is this D3N cache changes for RGW. I think that went through a QA test. I don't know if it actually passed or not, but Matt did a couple of additional reviews on it, so it looks like there may be some additional work that needs to be done. Other than that, I didn't see any updated PRs this week. Anything I missed, guys?
Hi, Mark. You probably missed my PR about optimizing placement group removal.
Then we should get that in. You have the pull number?
It's 37,314.
Do you want to talk a little bit about it?
Well, actually, that's first part of the changes on placement group removal, and it contains a couple of fixes which are unquestionable, so they're beneficial enough. The first one is to reuse next position when performing collection listing, and the second one is to immediately remove deleted nodes from the cache. This allows to avoid long collection ripping on final collection removal. Other than that, I have a more complex fix which introduces range deletes coupled with compact ranges. Well, for now it shows pretty good results, but unfortunately I don't have these slides ready, so I'm going to present next time.
Did you say that with range delete or delete range, you're seeing good behavior with doing? Is it extra compactions that you're doing?
Yeah. So the idea is to perform range delete followed by the asynchronous. So, well, actually, the idea is to queue range delete operation and then perform this range delete coupled with compaction, the same range compaction in a background thread. And also this compaction thread can match this range deletes and compactions. So instead of multiple operations, it performs in a single one pretty often. And well, for now I can see. So this means that we don't have these large tombstones in Roxdb for a long time. They are compacted shortly after the indication, and well, so far I can see pretty nice results. Well, sometimes there are some performance drops, but they are not massive, so they definitely look better than the original removal procedure.
Nice.
And from another side, these compactions look where they do not impact the primary operations performance. Well, the impact is not very large.
That's fantastic, Igor. That's exactly what you'd hope, right?
Yeah. But yeah, for sure, one should use range delete with care, since just a few number of tombstones result in insignificant performance drop scenarios. So that's why I'm trying to compact as fast as possible after such operations.
Yeah, I agree. Excellent. Okay. Anything else, guys, that I missed? I miss stuff all the time, so feel free to chime in. All right. Well, if there's nothing, then let's move on to the paper. Josh, I think this was your suggestion. Do you want to jump in? I read it, but I'm afraid I'd spend the next 10 minutes complaining. So.
Yeah, sure. I mean, I hadn't read that much beyond the abstract when I suggested it, so I don't take a. I won't say it. Let's leave it at that. But to quickly summarize, essentially, we're looking at trying to make more realistic workloads for evaluating Roxdb performance, and they took traces from 3 different applications at Facebook that ended up using Roxdb under the hood. That did fairly different things with it. Some of them used like multiple column families in different ways. Others were fairly simple, kind of incrementing counters. And they tried to decompose the different parts of a benchmark or of the trace so that you could get a more realistic synthetic workload that matched those traces more accurately. So as I recall, they had a few different aspects they focused on. One was kind of key locality, having certain hot read ranges of keys, which makes a lot of sense if you have like certain prefixes that you're using in different ways. And they have the concept of varying intensity in terms of queries per second or operations per second, which exhibited a strongly diurnal pattern for a lot of workloads. So they ended up modeling that with kind of more based on a sine pattern rather than a less periodic function. And essentially they ended up comparing the workloads they generated based on fitting the different characteristics of these workloads to more specific models for each of these characteristics with a generic YCSB benchmark. And they found that for Roxdb's case in particular, the workload that was closer to their traces had much different characteristics that more closely matched what ended up happening at the storage layer in terms of like reamplification and reamplification they saw than the more kind of almost more randomized and less realistic YCSB workload. That's kind of a brief summary. I guess there were two aspects, at least that stuck out to me. One was just looking at some of the trace data itself was a bit interesting, because of how small the keys were. I think like the largest, or they considered very large values, were 10K, which is still fairly small compared to like a lot of the keys we have in Ceph. And I think the concept of trying to very closely match a trace to with a synthetic workload using different models for different components of it makes a lot of sense. But it might be quite challenging to apply that without good real-world traces. So this paper did remind me that Roxdb had recently added those tracing capabilities. It might be interesting to try enabling those for some Ceph workloads and see if we're kind of doing what we expect we're doing.
So,
what tool were we using so far to benchmark Roxdb for our workloads? Were we using something like?
Well, typically, we're using higher level benchmarks rather than benchmarking Roxdb directly. There's something that, like, going through our one of the high level protocols on top of Ceph, even like RTW or RPD.
Yeah. I don't think anyone's ever tried to figure out how to simulate an OSD workload such that we could just run it directly with Roxdb in a standalone way. It'd be really hard, right? Because Ceph can accept so many different kinds of workloads, and if you run like an RBD workload, Roxdb is going to be used much differently than if you run an RGW workload, right? So you'd almost have to create separate models for all of this, and it'd be a lot of work.
Yeah, and beyond just the different access methods, I mean, you have many different patterns on top of those access methods too. Like a database running on RBD is very different from just a virtual machine serving a website or something.
I kind of question how much you actually need that. Like in the paper, they kept on talking about how different their workloads that they were running were from the real workloads, right? Like they were seeing much different cache hit rates. So, okay, yes, of course, that means that maybe you need to focus more, and from a performance perspective, on how well the caching is working, or maybe you need to focus on some other area depending on what the workload is. But as I finished this paper and read through it, I kind of was left with this, well, what have you actually accomplished? Kind of taste in my mouth. Like, okay, they showed that they can figure out better ways to represent these workloads. Great. Yes. That to me feels like the very first step in what should be a much bigger, more interesting paper. And maybe that's what this is. Maybe they are going to do that. But so far, I guess it felt like 17 pages was a lot to cover what they actually did here.
Yeah, I agree. I think there's a lot more that could be done based on that, but I think there's a lot of value in having being able to statically generate workloads that do match up with a real world workload. Because then you can measure that kind of performance without having to run all the upper layers, right?
Yes, I agree. I don't want to totally discount what they did because it is useful. One thing I would have liked to see is that they mentioned like YCSB using Zipfian distribution and how poorly that modeled. I don't remember which workload it was, but one of the workloads that they had that wasn't a good representation of it. But if I remember right, YCSB lets you control the way that the Zipfian distribution is laid out. Like it lets you change the scaling factor of it, basically. And I didn't see any reference in the paper. Maybe I missed it because it was a long paper, but or dense at least. But I didn't see any reference that they actually tried doing that. They didn't try adjusting the existing models to try to better match what their application behavior was.
I thought that was kind of implicit what they were talking about in terms of fitting the models to their application's behavior. Like when they described trying to fit different distributions to their traces. Like I would imply like varying the Zipfian parameters in addition to varying the power law parameters or varying the parameters for other distributions.
So I would have liked to see that, right? Like maybe I'm missing it, but I didn't see any evidence that didn't work.
I thought that that's what they did in section 7.3, where they were comparing the benchmarking results. They said that they configured YCSB to fit ZPDB.
7.3.
Like the second paragraph there. I thought that's...
So, okay, I'm looking at the section. We run YCSB with the following 4 different request distributions: uniform, Zipfian, hotspot, and exponential. We use the same preloaded database with 50 million randomly inserted KV pairs. Okay, that's all fine. Roxdb cache is configured. Yeah. So, okay. The total number of block reads and the amount of read bytes by YCSB Zipfian workloads are at least 500% higher than those of the original replay results. And so my question there is, did they actually try adjusting the parameters of the Zipfian distribution to try to better match the cache hits that they saw with the real results? That's what I was getting at.
Yeah. I guess I don't see them doing that with the real system, but maybe more in the modeling phase.
As far as I can remember, I think YCSB has something called read latest, and you can also give it a distribution of how much you want it to read, what based on time, and also proportions that I think everybody knows. So I don't see that being used.
The feeling I got was they were like, okay, let's try these different ways of setting it up, a uniform distribution, Zipfian and hotspot and whatever. And they tried it and it didn't work. So they're like, oh, we need to make a new benchmark. because this doesn't work right, and they didn't
I think it was more than
maybe
that. I think
yeah.
in their they had a very brief paragraph about it. I think they didn't go into as much detail as would make it clearer. But at the end of section 3, they describe just looking at the correlation coefficients and then between different factors, separate them out, and then fitting different types of curves to those different factors and finding the curves that have the lowest fitting error to each of those factors.
Mm-hmm. I
So
may have skimmed over this.
I think that's the part where the like they would have considered like differences between parameters, but they didn't really show the details of that process. And yeah, to your point about the ICSP having other parameters they could have used, that's interesting. I'm not as familiar with YCSP's current state, but it sounds like those might give them some of what they were looking for.
Yeah, I mean, I'm not super familiar with it, but I have used it in the past, and I know that they have a bunch of tunables that you can tune to model workloads, and that's the reason it's such a popular. It has been in the past, at least. And it just seems like they've been like, okay, we're not going to experiment too much with this, and we want to, as Mark said, we want to just create something that works for us better.
Mm-hmm.
Yeah, that was my understanding too. I'm not super familiar with YCSB. I've used it a couple of times, and it seemed like you had the ability to like tune things a lot. So I have a very much the same feeling you do. It seems like they, well, I don't know. Maybe they really did look into it, and maybe they determined it wasn't sufficient. But it would have been nice if they had fleshed that out a lot more.
Mm-hmm. Yeah, I suspect there may be some pieces here that are kind of more in depth with respect to like the cumulative pair ranges and sizes. They mentioned trying to contribute some of that to YCSB in the future.
Did anyone have a chance to take a look at? I think they said they released. I think they said they released some of the tools already. Open source the tracing, replaying, and analyzing.
Yeah, the tracing stuff has been in Roxdb I think for the past year at least or something. But I don't think we've tried it out really, unless you've done some experiments, Mark.
Nope, I haven't looked at that at all. But yeah, actually, I mean that could be useful for us, right? Potentially, if we were able to do traces on a Ceph workload and replay it with dbbench, that could be interesting if we could make that work.
I think with some of the changes we're looking at, it would be very interesting to see what effect they have on the behavior we see in the traces.
Yeah. I mean, historically, my view on a lot of this was just to make it as insanely fast and easy to set up a Ceph cluster and run tests as possible. But presumably, you could go this way, right? You create some kind of very, very, or maybe a variety of different workloads, and if you can just run it directly with dbbench against Roxdb, that would be even potentially faster and more useful, maybe.
Yeah, I guess I was thinking it could be useful for like analysis in addition to a kind of running a more isolated benchmark. Even if you, it's just seeing what kinds of workload we end up giving for Roxdb, like for example, before and after these PG log changes. Seeing if that matches up with what we expect.
I see. So rather than recording the trace and replaying it later, actually just doing the trace analyzation.
Right.
Yeah. I mean, maybe. Do we? Sorry, I kind of started honestly tuning out a little bit by the end of the paper. Did they give kind of an overview of what all the tracing is capable of?
I think they had a brief overview towards the beginning.
Okay. Tracing. Okay. Yeah, I see here under on page 212, I guess, which is the same thing as page 5 in the PDF. It looks like that's where.
Yeah, section 3.
Yeah. I'm a little surprised that they said that the lock being used to serialize all queries doesn't cause any performance overhead in their observations. That's interesting.
Yeah, it might be interesting to test it, and then I just implement tracing with a Ceph code to see if there is any, if we can notice any overhead there or not.
Yeah. You know, it's interesting because if you look at Ceph OSD and you look at the number of records that we actually push into Roxdb, we're like, you know, people talk about the number of records that they do, and we blow it away. I mean, a single OSD like just hammers Roxdb.
Yeah.
We're almost like our own version of a workload generator.
Right. With the record sizes too, like these ones are all incredibly tiny compared to a lot of the values that we have. Even the keys that we have.
At least one of the things I've noticed when I've looked at, you know, like other people using Roxdb and the sizes and the amount of data they're talking about, I'm like, well, geez, we can you know, do that in like a half an hour or less on a single OSD with a big, you know, RGW workload.
Mm-hmm.
So, okay, difficult to track large-scale and long-lasting workloads. That makes sense.
Yeah, I guess another note that was important for like the tracing aspect was they looked at both large scale, like a 14-day period of time for analyzing things, but also just a trace over a single day as well, since the workloads will change quite a bit over that period of time. So if they have like different things running on different days, I guess that's an important thing to keep in mind if we thinking about doing tracing in the future.
How important do you think that is relative to just identifying different common workloads that people do? Like, do we need like trying to think of how to say it, but once we have an idea of what a particular use case for a cluster is it actually that interesting for us to see the day-by-day changes of how it's being used, or do we kind of have a good idea of, you know, kind of generally what people are doing on that particular cluster?
I think it's a good thing to be able to verify that. Like if you think a cluster is being used for one thing, and you look at that cluster over the course of like a few different days and see if there's different patterns that you see on different days, that would be a useful signal that maybe there's something unexpected going on, or seeing maybe more than one type of workload.
Yeah. I guess what I was wondering is, do we need Roxdb statistics to know that, or once you see certain kind of client requests happening, will it just kind of fall into some category of I/O?
I think you probably want higher level data for better workload characterization. Like the lower you go, the harder it is to get back to what was originating the request and how.
Sure.
Like if you're, at the OSD level, you only have one view of things, but a file system level, if you can get data from like the file system client, that's a lot more detail.
Yeah. I guess what I was thinking of is like, okay, RBD, the Roxdb workload is probably going to be very well known, I would think, right? Unless you start really changing things like making really small object sizes or something. I'm guessing that a lot of RBD workloads are going to look a lot like other RBD workloads if they're the same kind of the same kind of access pattern, right? Like if you have reads happening, depending on how much cache you have and how many O nodes are being read from cache, you're going to have more or less Roxdb key lookups for those O nodes, but those key lookups are always going to look kind of similar, I would think. Is that a good assumption, or am I wrong on that, you think?
I guess you're wrong, Mark. I've seen
Okay.
workloads, RBD workloads, and they are very different from OSD to OSD, working similarly at the same time. So it even depends, especially predominant is that from time to time, there are like streaks of set of very small writes. So it's basically like other time, it's just like keeping large writes, just keep coming slowly. And then there's a fast burst of small writes to different objects. So that's what I've seen. And the patterns are really, I couldn't see any patterns in those patterns.
What kind of workload was that, Adam?
Josh, that was the capture from a customer 24-hour capture of RBD working on customer cluster. I don't know which customer that was, but it was extracted from RBD traces.
Yeah, I don't think we know what the workload was exactly.
So the behavior in Roxdb was really random. You said it was writes but not consistent and bursts at random weird times?
Actually, I cannot confirm that. I can only confirm that the patterns incoming were very different from different time points and different OSDs. Of course, they translate a bit to more order on Roxdb side, especially because we're using the same objects, for example, often. But it couldn't be inferred that if I had a streak of small writes for some time, then it will continue for a long time or devolve into larger writes. It's just unpredictable. Sometimes it abruptly stopped, and sometimes it turned into large writes. One explanation could be that I've been seeing different workloads actually mixed, and I've only seen results on OSD side, and I couldn't infer actual workings from just RBD object names.
My assumption was that say if you had an RBD workload, you would always see some amount of, well, except in the perfect case, you'd always see when you're doing writes that you'd be doing onode reads to make sure that an onode exists. And potentially you'd always see fixed size key values coming in because RBD has fixed size keys for the block layout. But with RGW, you'd see very different behavior, right? Because it could be all over the place. You have many different key sizes. You have potentially crazy kinds of workloads depending on whatever the client is doing. I guess my hope was that RBD would be more consistent, but maybe that's wrong. I don't know.
Yeah, I think you'll see many different kinds of workloads on top of RBD that result in many I/O patterns. I mean, at the base level, they all have 4 memory objects, and you expect to see kind of more small random I/Os in general, but I think it's a pretty broad generalization.
Fair enough. So what can we get out of this? We talked about the tracing stuff. So okay, maybe that's useful for us. Is there anything else useful for us here?
I think if we're trying to do some benchmarking with more realistic workloads, the idea of kind of trying to model them at more fine grain might make sense. For FIO, for example, I'm not sure if it has similar kinds of options in terms of controlling locality. Mark, you're probably more familiar with that than I am.
Yeah, I mean it does. And you can also do the same thing with FIO that you can do with YCSP regarding Zipfian distributions, parameters of the Zipfian distribution. You can really, try to better model what it would look like if you were doing most of your reads out of cache. And we've done that in the past. So yes. The thing I don't like about it is that what it ends up doing is it really kind of de-emphasizes the performance of Ceph or the impact of Ceph, and kind of more just focuses on how fast you're doing, reads from cache, which are kind of completely uninteresting as far as actually making Ceph better. Maybe it's interesting for the customer, because if they can say, well, if 90% of my reads are coming from cache anyway, then it doesn't matter if the storage is not super fast or slow or whatever. But I don't know. I mean, from a perspective of giving the customer a valid, a good representation of what their application is going to do, yes, maybe it is interesting.
Yeah, I think it sounds like you're describing in general what when you'd want to run a benchmark or a more realistic workload versus when you'd want to do a more targeted benchmark.
Mm-hmm.
And I think those kind of more realistic benchmarks certainly have their place in terms of testing regressions and seeing what a user would actually see from different changes we make.
Yeah. And Jens has actually done, as far as FIO and the block layer goes, I mean, he's done a lot of the things that they talk about in this paper with, being able to record traces and replay traces on block devices, and even FIO has some support for this kind of thing built in. And FIO does give you a lot of control over, what kind of access patterns you want to create and layout of files and things. So, I mean, yes, you have a lot of control. I don't know. It's probably valuable. It just seems like it's really easy to get complacent when you start doing this and saying, well, everything looks, really, really good when you start modeling these workloads, but then you maybe can easily overlook corner cases where things are bad.
Yeah, I think you definitely need both. You can't just rely on one kind of test. Right?
Yeah.
But as we're looking at like different sorts of access patterns, like AI/ML stuff on top of RGW, for example, like that's a probably totally different access pattern from what we see with other things for RGW.
Well, right now, with something like MLPerf, we see access patterns that are completely ridiculous because everything is basically coming in cache. So I can actually show you graphs of a real MLPerf run using a couple of different data sets. Just one second. The real problem is that they don't actually represent the kind of things that like Google or Facebook or Amazon are doing, because we literally do not have the ability to test data sets that big, nor do we have access to data sets that big. Here we are. One second. Okay, so this is the result of actually using the MLPerf test that NVIDIA ran to showcase performance on their DGX1 AI ML kind of reference architectures that they built. And this was run in our Alias lab, which has very slow GPUs. It took forever and it was not super interesting, but the gist of this is basically you see a big spike of reads at the beginning, not even that big. It's kind of pathetic, to be honest. But there's a spike at the beginning in both this GNMT, which is an German to English translation, I think, and then also the SSD test, which is an image workload. I don't remember exactly the exact details of the algorithm, but doing some kind of image recognition work. But very similar in both cases. It's all out of cache. It's super uninteresting for us. We need like 3 terabyte data sets, big data sets, real data sets, to actually test what's going on.
Yeah, that certainly seems like the case that's not really stressing the storage.
Exactly. But this is the benchmark that's used. This is like the industry standard. Everyone that's doing GPUs is using for this kind of thing. But it's completely uninteresting on the storage side. It does not even remotely represent what like a very large AI workload that real people are doing would represent. And maybe this is where tracing helps. Maybe this is what we use it for, right? Maybe this is a justification for why to actually do this, is that getting access to these data sets is really, really difficult. We can't, either we're going to have to generate data sets that look a lot like the real ones and then run our workloads against those, or we need to get traces of real workloads and then replay them.
Yeah, I think that's definitely a viewable approach. And I guess a common issue in the past has been the difficulty of gathering traces from like large scale users of things like this. But if we can do that, we can replay them on even smaller scales.
To play the devil's advocate a little bit, though, say for this SSD test, this is basically going and performing image analysis on what used to be a large data set of images, like, I don't know, I don't remember how big it is. It's like maybe upwards of 50 gigabytes, but it's something like that. It's small enough that now it fits in memory, in main memory, so you just hit page cache. But say it's 50 gigabytes of images that are like, I don't know, on average between 64K and 128K in size. do we actually need to run this workload, or is it enough to say that you're just doing random reads of images into memory, and for whatever memory amount you have, you have a certain cache hit rate, and some of these are going to be read from disk. I think that's actually all this is random reads, random loads of images into memory from a pool of images that have a size, a standard distribution and average size. It may be that this is actually not that interesting, right? That's, I guess, what I'm getting down to.
Yeah, it could be. I think there's certainly other workloads that do stretch the storage where it is interesting, though.
Well, I mean, we'll stress the storage. Certain. Sorry, go ahead.
Maybe I'm misunderstanding what you mean.
What I'm saying is that we can generate load. It's not that we won't be able to generate load, but it's just that all this may end up being is how quickly you can load files that are moderately large, between 64K and 128K, into memory, given some amount of page cache on the client and read cache on buffer cache on the OSD. You could simulate it really easily, right?
Yeah. No, I agree. It's definitely not. If you know that that's what the workload ends up doing, because it has a small data set, then it doesn't make sense to try to model it more accurately, because it doesn't make a difference for the actual storage workload.
Even if you had a large data set, though, right? All it might end up reducing to is how quickly can you read files in a range of this size, given a certain cache hit rate and a certain amount of memory and a certain likelihood of hitting the same file.
Yeah, I agree that I think there definitely are workloads that are, I guess, simple enough for that you don't need more accurate modeling to get a general idea, a good idea of how they would perform.
Sure.
I think that's kind of one thing that stuck out to me from the paper. Like, Roxdb is a fairly complex system with the LSM tree and the different things it does to try to manage that. So that's one reason why kind of more accurate workload modeling might be quite important there. With something like
sure,
maybe doing like immutable object reads. I mean, that's a much more simple workload in Ceph.
With Roxdb, the other thing that complicates things is how big your data set is and how it grows, right? Because that really changes the dynamics of how it behaves.
Yeah, exactly. That's what I'm getting at. Like, with the LSM tree structure is very complex, whereas a single object lookup in Ceph is not going through it at that same kind of structure, or a single write isn't going through nearly as complex a I/O path.
Did they talk in the paper at all? And I apologize if I missed this as I was going through it. Did they talk at all about the size of data sets and how behavior changed as those changed?
They talked a lot about the size of data sets and the different sizes of keys and values. I don't think they did a lot of analysis on the variations caused by that necessarily.
You could imagine that if your model is wrong, the bigger it gets, maybe the more the errors diverge. Maybe not. What I was thinking is if you end up in a situation where the database itself is being more strenuously hit. That as the database grows, you end up with more time spent in compaction and more likelihood of hitting situations where you're blocking, right? Like you're blocking on a specific level as being compacted. And so your cache miss potentially could become a lot more severe in a situation where you have a lot of data versus when you have a little bit of data.
Certainly. You could definitely see some effects from like that kind of like working set size, like or scaling factors for the data set size that you wouldn't see the smaller data set. Yeah.
That'd be kind of interesting to know.
Mark and I have been talking a lot. Anyone else have other thoughts about the paper, or tracing or modeling workflows in general? We've got a few minutes left. Do you want to dive into the other discussion we started at the stand-up with Gabby and their more detailed look at Roxdb?
Josh, are you talking about from stand-up, the discussion we had going there? Okay.
Mm-hmm.
Yeah, I'll be glad to.
Go ahead.
Should I start? Okay, so what we try doing is, at the moment what we do is that object node goes to Roxdb as column family A, and we got a pglog going to column family B. For pglog, we never want them to go to disk. We just want them to be on the same write-ahead log as the object node, which is why we put them in Roxdb in the first place. So, and the problem is that the way we deal with them is that we create log entries, but when the object node reach the disk, then we create a delete entry, which becomes a tombstone, and these things tend to stay forever because usually you have to propagate them all the way to the last level before you could remove them. So instead of doing add entry, put entry, and delete entry, we decided to try to use something like a recycle value. So we never delete anything. When the object was this stage, then the key is being recycled and assigned to the new entry. So we just keep updating the value with the same key, but we never remove anything. And we hope that way we're going to get away from the tombstone and all these problems. Because in theory, because our mem table is going to be very small, we have now like 3,000 entries. With just 3,000 entries, we assume that we could keep the mem table in memory and never go to disk. It didn't work. Mark did performance analysis, and we do now double as many compaction operation. So I start reading Roxdb document, and I realize that our design is not going to work the way it is, because what happened is that the write-ahead log can never be removed until all the mem tables which assign entry there be in this stage to disk. So, and because we never delete anything, what happened is that the write-ahead log become bigger and bigger and bigger. At some point, what happened is that they take the mem table for the pglog and stage them. So everything goes down and they propagate all the levels without ever being deleted. And what happened before is that in the older code, things used to be put and delete, but because many of them been happening while stuff still being in the mem table, then they never reach level 0. It was a lot of extra work on the write-ahead log, but they never reached the level 0. So our solution was doing worse than before. And now my understanding is that if we want to get performance, we need the write-ahead log to be deleted. So we need to find a way to allow to be deleted and still never get, without ever staging the mem table for the PG log. So the way the write-ahead log is being deleted is every time a mem table, so sorry, all the mem table from all the column group, all the column family, all go to the same write-ahead log. Whenever one of them is being filled, or for some reason somebody is calling flash, so this thing is being staged to disk, and now it's all safe. And what we do is that we create a new write-ahead log, and the previous one is set aside. And now everybody moves to write in the new write-ahead log, but the old one cannot be staged until everything which been written there being flashed to disk. And my understanding is that the way this thing is implemented, that every time the mem table is destaged, sequence number for that mem table is incremented. And every write-ahead log is keeping the highest sequence number that was used for every column family. So to be able to delete it, you need to make sure that all the mem table that have copies there, all of them being distilled, which means they move to higher version. Does it make sense to everyone until now? I actually wrote all of this in my email today, so I think it's going to be easier to follow if you have this email next to you. So we need to find a way to fake the mem table flash. So I was thinking maybe we could do everything which is done for the mem table flash, except actually flashing. So what happens is in the mem table flash is that we we create a new write-ahead log. We increment the mem table sequence number, and somehow the old write-ahead log is being updated with our new version. So he knows that he can ignore everything from us because we moved all the old version being this stage. And now it only have to wait for everybody else to this stage and report that they moved to the new level, the new sequence number, and then this thing can be discarded. So I'm trying now to find the code doing the flash, and hopefully we'll be able to do these things. But it's a dirty hack, because the code never intended for this to happen. I'm still trying to find on a logic which could allow this. Maybe we could design a mode which say discard, mem table discard. So by doing mem table discard, logically it should allow everything in the write-ahead log to be removed. But if we really want to do this, it means that we also need to remove the mem table, which might not be the end of the world. So instead of using a single mem table for the PG log, we could use two of them, and every time we fill one of them, we just call discard. Every time we want to trim everything there, we can call discard, and then that will emulate the flash, but without actually writing everything. Does it make sense? Because I mean, the ugly way is to call into flash. Yeah, okay. So the ugly way is to call flash, but don't do the flash. Just do everything around. But that's really ugly because it's have no semantic except, and anybody going there just like, why these people doing this? That makes no sense. But if we break the PG log into two separate mem tables, then we could use like double buffering, and whenever we finish with one of them, and everything until that things we know being this stage, all the object node that we open PG log for them up to that point being the stage, we could call the equivalent of trim, but we could say discard. There must be a way for people to say, you know what, forget about this mem table, I don't want it anymore. So if you don't want it, you could discard the write-ahead log, and you don't have to write everything. So the whole thing being freed. So I'm still trying to find if there's an actual way to do that. because that would mean that we will have to keep creating and discarding mem tables. I don't know how expensive this. Need to check this. I need to find if there's a way to do that. If not, maybe we could just add an API like this. And
it seems like you
extra. Sorry.
I was just going to say, it seems like you could do this in a way that's universally useful for Roxdb, right? Because that's if we want this upstream, that's the ticket.
Yeah, that's why it have to be discarded. Cannot be just hacked.
Exactly.
And if we know, we can even create a mod in mainframe. They have a mod when they do write. They have a flag to say, I'm writing to temporary file. So keep it in memory, but never put it to disk. I need to remember the name for this. There's a name for this. So we could maybe call it it's like a temp file, like a tempfs. So we could make a mem table which is tempfs. We still want to create the write-ahead log, but once we decided to remove it, then the whole thing can be trimmed. The memory is going to be trimmed, and the write-ahead logs could be discarded. And also, to make it a bit more efficient, the default behavior for memtable is a skip list, which is very efficient if you want to keep everything ordered, because the SST have to be ordered. But if we know that this thing is a temp file, which never going to go to disk, then we don't need the ordering. So we could use, there is a linked hash table. So we could use just hash table, which is going to give us faster performance. Oh, just 1 second, sorry. There's somebody in the door. Yeah, sorry. So instead of using the skip list, we could use the hash table, which is going to give us a faster access for read and write. Actually, sorry, not a, just it's going to give us faster access for update, read and write, and whatever. And we don't need a skip list. But that's just a secondary improvement. But we need to have this. So there's memcache, for example, right? I mean, memcache doesn't need anything to be persistent. So we could have something like that, like a temp mem table, which it's possible to get to be discarded. And sometimes things get discarded because, you know what, we found some better place to store them. We move them to somewhere else, right? I mean, what happens if your mem table is being migrated to somewhere else? You don't need to store it anymore. Still doing key compression. Yeah. Oh, I mean the skip list. Yes, right. Yes.
Yeah. So I just wanted to. Yeah, I just wanted to mention very briefly that it could be, even if it's a side effect, it could actually be a really important one.
Yeah. I mean, and also you don't need what is this? Big O of log n instead of. I know that n is not very big; it's 3,000. So how much is log n of? It's like maybe 14, 15. So maybe it's no big deal, but still, it's nicer.
Right now.
Hash table.
So 3,000.
To keep it small, right? We intend to keep the pglog small.
The question is, how valuable is pglog at n equals 3,000 if you have the ability to do 1 million write apps?
Yeah, but you don't need. Oh, I mean the millions. So say you're doing 1 million IOPS, but actually you finish every 10 milli, you finish 10,000, right? So if you
yeah, exactly. How much?
It just means your walking set needs to be in the pglog. So maybe it's going to be 10,000, but you don't need. If everything finished within 10 milliseconds, you don't need to keep a full seconds of pglog.
What's the value? The question is, what in my mind is, historically having pglog helps you avoid the situation where you're going into actually looking at objects on disk for recovery, right?
Yes.
It's that, and it's also
You can do
correctness
replay.
with the PD dupes. You still need the dupes regardless of recovery.
Yep, that too. We have to scale it, I think, if we keep with this model. It's one of the
I
things
do
that
like
keeps
the
me
idea
up
of
at
like
night.
the double buffering with like if we potentially even don't have as much of the log itself, but more more focus on the dupes, because those are very much time bound. If they're not useful after, if you're not going to see requests being replayed, minutes later.
So in my side, I'm still digging into Roxdb code. I just started looking at the actual code today. Until now, I was just reading document, and there's huge amount of documentation about Roxdb, which is really cool. A lot of explanation, a lot of case study, and everything, which how I got to understand this behavior. But everything I did until today was just reading document. I didn't read the code itself. So now I'm diving into the code itself, and I'm still trying to understand the structure, which object is doing what, and where are they located. So it's going to be time-consuming, I'm assuming. So if anybody here is familiar with the code and can give me a crash course on Roxdb code layout, I would be very happy.
I can't probably in the way that you want. I've got a piecemeal understanding of certain parts of the Roxdb code, but not kind of what I think you're hoping for. Adam, you've looked at it as well. How do you have?
That's
Do you
true.
feel confident?
I'm not confident. I can recognize pieces and places, but it does not form entire pictures. So I can be help, but not a guide.
That's how I feel too.
Okay, so I'm going to be the guinea pig. I'm going to try to do it my way. So I think I understand the semantic, and I also read about other databases because, I mean, write-ahead logs behavior is common to all key value databases. So I read it also in other database design documents, and they also mention similar behavior. So I think it makes sense that that's the way to do it. And it's actually an efficient way to do it. Like yesterday, I was still under the assumption that there is a code walking the write-ahead log one entry after another and just purging them. But it's very inefficient, and it's pretty stupid to think about it. So once I read about this thing using this versioning, yeah, everything makes sense. So and I've seen it also. LevelDB is doing the same thing. I think Roxdb is a successor to LevelDB. Some of the document I found was under LevelDB, some under Roxdb, and there was somebody else. But I think all of them are just the same family. So the behavior makes sense. I'm still trying to find if there is a way to do purge, discard memtable. And if that could be done, then I don't have to do anything. If not, then I have to add this code to do memtable discard. Because the thing I suggested in the email is pretty ugly, right? I mean, you pretend that you flash, but you don't flash.
I think I will be very interested in your opinion when you've done all of this research and looked into it, if you still think that it's good to do it in the Roxdb log or not. That's the question I keep asking myself.
So the question is, and I cannot make any judgment call here. What Sam told me is the reason they put pglog in Roxdb is not because they cannot use another write-ahead log, is because they wanted it to be consistent with the object node. They wanted all to be in complete sync. I don't know if
Yes.
it's critical. I didn't try to think if there is a better way, or sorry, if there's another way to do it while using separate write-ahead log. I mean, we are doing a lot of crazy work just to benefit from having write-ahead log without actually using a database.
Yeah, I think the main reason is for HDD case, like where
For what?
it's
Sorry?
really expensive. The hard disk case, where it's really expensive to have multiple extra IOs you need to do.
Oh, okay, I get it. So we
Yeah,
try to
yeah. I mean, you
integrate
could
all the rights.
you could do
Yeah,
a
you put all the
three-way.
writes together with the one write-ahead log instead of having multiple of them having to seek.
Yeah.
I guess that actually on SSD it's even more expensive because of write amplification.
Essentially, yeah, in terms of
How
verification.
big, how big is a PG log entry?
It's not going to be. It's going to be much smaller than a flash block size, most likely.
Maybe. I mean, when I was doing 4K random writes to RBD, I was seeing in reality like 7K writes to the write-ahead log. So
Yeah, but
if it's a
that
4K,
includes the object node and the PG log.
yes.
And the data
So
if
I'm
it's
assuming
for
that
certain
the
writes.
object node is bigger.
That's true. But if your object name is bigger than an RBD, then it might not be.
Okay.
It's gonna be like a few hundred bytes probably for the object names.
Yeah,
I wouldn't think
maybe.
that
Okay. Yeah.
the PG log is going to be that much
But
larger.
few hundred that's the RGW case.
Yeah, where the object name
Yeah,
itself
not
is like a
RBD.
couple hundred bytes.
Yeah, but if you think about RBD case, so the object name is like 32 bytes.
Yeah,
Something
So you're
small.
probably going to be wasting huge amount of space if we stage every single PG log entry to a standalone sector. But are we trying to do any coalescing of PG log writes? Do we try to
Well-
aggregate many of them and stage them together?
that's
You
another
see,
reason we're
that's
using
exactly-
Roxdb.
Yeah, that's exactly it, right? Because if you start going down that path, that's a very different route than what we do, right? But
It's
that
essentially
is a
kind of
potential.
running a little database with its own little buffering layer and
But I think Roxdb is doing this on every IO. It doesn't do this aggregation.
no, it doesn't.
It gives you an option to.
Yeah, but we do it.
You
We
can control it yourself.
aggregate it.
Sorry, so we do our own flash call. We do our own call to flash.
We aggregate writes to Roxdb, and on certain synchronization points, we just tell that we need that batch that we already have written to land safely on disk. So we force it periodically. I mean, often, but periodically.
Yeah, okay.
Well,
So in that case, we could use it also for the write ahead. If we make a standalone write ahead log, then we could do the same thing, aggregates, and then it's not going to be that bad. And I was even thinking we could start doing that. We don't have to wait for the write to actually happen. We could start every iteration that somebody, the dispatcher, is poking in all the queues, and you can say, oh, I can see there's a request here. So he's just going to take the list, create a write-ahead log, send it to BT stage, and only later go and start processing the write. So he could do it ahead of time. Really, so it's going to be write ahead log, whatever. Read ahead plus write ahead. Plus, yeah. So you do read ahead into the future. If you have command queues, you know the future.
I don't believe we can. How would we then recover from sudden loss, restart, or event like that?
Sorry, I didn't get the question.
I'm not sure we can do that. How, if we do it that way, so have writing as a future to our older writes, how can we then synchronize properly? Now we just blindly trust Roxdb to batch it only one transaction, and we are synchronized just because all of those mechanisms that are already there.
You could batch it yourself, right? I mean, if you look at the future and say, oh, I can see there's going to be like 15 new writes in the future. I'm going to create one big entry describing all of them, send it to BD stage, and then go ahead and process them after this thing BD stage to the write ahead log. You could just build your story, right? I mean, you could read and you say, from the queue, I could realize that we're going to have that many writes. Let's put them in the write ahead log before we even start processing the writes. So you might have some cases in which later you're going to decide that, you know what, you don't need to do this write because of some reason there is some mistake in a write. But it's very uncommon. So you could send a tombstone you could just do like an undo in the write ahead log for that action. But in vast majority of cases, you don't reject write. I mean, the reason to reject writes is usually if you're running out of resources, or if there is something wrong with the request, permissions, I don't know. But you don't expect this to happen. So again, I mean, I'm still not really sure I fully understand what is the semantic of the write ahead log. Sam was pretty hard on this, that he wants consistent view system-wide between all the column families and object node and PG log. Everything need to be consistent in the same write ahead log. I'm not sure why he wants it, but he wants it. So, but I don't understand the system enough to say we don't need it. Actually, I don't understand it at all. So there might be an extremely good reason why everything have to be together. But maybe it is possible for us to batch them together. Just make a plan of what we're going to do. We're looking in the future, we could poke all the queues, and we could construct descriptions of our future work, send it to the write ahead log, and then in our own good time start processing them. And then do it from time to time. Every time you reach some point, you start looking in the future and building your write ahead logs. But I need Josh and Sam to see if there's any merit to this concept.
Josh, Sage and I talked about something kind of like this a long time ago, and there was some reason I keep forgetting why it's difficult to have separate instances of like a write ahead log per PG. There's some reason why we can't do it without some extra work.
Per PG, I think there was some existing structures that aren't specific to PGs, like the snap mapper, I think was one of them.
Yeah, that might have been it.
But I think that's not a fundamental reason. That's an incidental reason. We could change that way that works. But I think like I guess the general idea with the one single write ahead log is to avoid those extra IOs essentially. And the single point write ahead log is a really simple way to keep things consistent in a single transaction as well. It's possible to do it in other ways with multiple write ahead logs. And doing it per PG probably a lot simpler than other ways. But if you do it per PG, we also lose some of the batching ability that we get from having all the PGs going to the same write ahead log.
Why should we make it a per PG? I actually, it makes more sense to make it as big as possible, right? To cover the bigger,
I think
so you are more likely.
I agree. I think it makes more sense to have it larger.
But the dispatchers are working on a per PG, right? The dispatchers don't see all the future. Every dispatcher just see one PG. Is that correct?
Yes, although the KV within BlueStore, for example, like the KV sync thread is aware of everything that's that's been submitted.
I have a feeling we don't necessarily want it per PG, but we may want multiple ones to achieve parallelism while still having a good ability to do batching.
I mean, is there an experiment we could run that would tell us whether like more parallelism would help, or whether more batching would help?
Right now, maybe not. We know that in the past, the KV-sync thread has been a source of contention. And actually, originally in BlueStore, it was very slow. It was the primary bottleneck we had. We've improved it dramatically. Now we can do about like 70,000 write IOPS in a single OSD before the KV-sync thread becomes a major problem. And we're not there yet for a real cluster. We can do it in isolation. But at some point, if we want to do better than that in BlueStore, we may need more parallelization than a single thread.
Adam, I think we could just remove the code during the pglog stage. I mean, just don't send anything to the pglog. So that way we could see how expensive is the pglog.
Yeah,
Just
I think that's a good idea.
There's a code.
I think Mark, you did some of that like last 2 years ago or something.
Yes, I've got results. Just 1 second. See here. I believe that was this document.
It's for performance is good enough.
This is what we see when we remove
Guys, did you
pglog.
hear me? I everything froze for me. So did I speak to myself?
Yeah, I heard you.
Myself? Okay.
Yeah, I heard you.
At least you were talking to me.
Okay. Because I mean, talking to myself, it's interesting, but.
What was the last thing you said? Did you say that for performance it's good enough? Was that the last sentence?
Yeah, I said because by all this faking, if we remove the code that calls to pglog the stage or just aggregate instead of doing one by one, do them every n entries, so we could measure the performance impact. And there's, of course, we're going to lose recoverability because if we don't write it or if we wait, then the semantic of recovery is not going to work. But we don't care about this for now. We just want to see how expensive it is. To see.
Look at the Gabby. Look at the link.
Okay. So no pglog OMAP. So you did try. I'm not sure what's the OMAP. So no pglog means we don't stage any pglog.
So no pglog means we actually comment out all the code where we're actually doing all the calculations for pglog. No pglog OMAP means we still do that, but we don't actually send anything to the database.
What do you mean with?
No pglog OMAP means that we basically short circuit sending the data that would have gone to Roxdb in OMAP. Yeah. We just don't do that anymore. We just, don't actually send that data to Roxdb. The no pglog case in general means that we don't even do the calculations necessary to compute pglog.
Okay,
so one is database, one is.
Probably the red one is the more interesting because even if we be extremely efficient in the way we do things on disk, we still have to do something. So the yellow thing is probably cheating. The red one is like our best case scenario.
Yeah, yellow is to give us the upper bound on what we could do if we also improve the in-memory processing of pglog, right? Like if we could, make it much, much faster, then that's the upper bound of what we get.
Okay. So what do we see? We see that the IOPS are not much better.
This may have been from before we did the the O-node cache restructuring in BlueStar. I don't remember. It's relatively fast, but it's not that fast because we've gotten better results in this. So
we got like 10% extra IOPS, and the latency on the first case, it's about 15% better. The fourth case, the latency is way, way better. I'm not sure what's the difference.
Tail latency, 99 percentile.
Oh, okay. So you cut the which, like in the previous system I was working, there was a requirement that the average and tail latency, they cannot be more than like 10% difference. There was like huge effort to stay away from tail latency. I don't know if Ceph is really that concerned about tail latency.
Our tail latency is huge.
We're concerned about it, but we haven't designed the system in such a way that it is possible to get that low of a gap yet.
Yeah, I can tell you, like, system designed to be like this, they are sometimes crazy because in some cases, the normal flow was being much more expensive than it should be, just to make sure that the tail latency is not going to deviate. So I don't know if it's like very achievable goal if you don't design your whole system for this. But I mean, it's always good to try to.
I think best effort, right?
Well, I think it's one of the goals with CStore to improve that tail latency aspect by not using Roxdb.
I think it's worth
that is more designed for that, like maybe slightly increased average case, but much lower tail case.
So what we see is like 10% extra IOPS, 15% less latency, which is very nice. So, but that's like the best we can do. I mean, people usually will go dancing if you give them 10% extra and you cut down the latency. But so that's
question. Well, yeah, and the question though, right, is those are the numbers that we see with the current or of the code at the time that this testing was done. The next question though is, okay, every single bottleneck that you remove, everything you make faster, sometimes it could be that we'd see more, better results with this if there wasn't something else in the code that was slow, right?
Yes, but could also be worse, right? I mean, no, actually, I don't think it should be worse, but yeah. So how difficult
is it worth then rerunning?
to get this thing?
Josh, what were you going to say?
I was asking, is it worth rerunning this kind of experiment again with today's code?
Could be. Been a little while since we've looked at this stuff. I wonder, though, if we should Gabby, you tell me, is it worth having you continue your research into Roxdb and trying to prototype, or would you rather have updated numbers first before you go down that path? So I can redo this.
They can be done in parallel. Next week is pretty slow here. Sunday, Monday is Yom Kippur, which is a big holiday here, so everything is shut down. So you do have some time, and actually, I think today is my last day until Tuesday. So next time I'm working is just Tuesday. So that gives you some head time to do things. And you know what? Even researching Roxdb, it's very interesting. So I don't mind spending time there. Worst case scenario, I'm just going to learn things and maybe find better place to use them or other places to use them.
Yeah.
The more we understand Roxdb, the better we'll be able to use it.
I think my slight hesitation with doing this over again is just at some point, all of this is kind of pointless, right? Because Crimson is the real future in making all of this kind of thing good. And this research helps us, but what I want to avoid is for us to end up doing a bunch of work studying a problem that we may never really get around to fixing. So if we're serious about really changing Roxdb, like really changing some of this stuff, then maybe we should do it. But it's a lot of work.
I think you should evaluate how long it'll take, because I think before there's a lot of time until like C-store will be ready, or for a stable release. So I think it's worth evaluating how long the changes you talked about are going to take.
If we want to change Roxdb's write-ahead log, we need a plan to actually make it feasible. Well, we at least have to change it in our fork of Roxdb. I don't know that we're ever going to get it upstreamed. Maybe we will, but I don't have a lot of hope for it.
So my idea was not to change the write-ahead log, but to create some modified version of memtable in which you could call purge. And by doing that, and then just utilize these things.
If I remember right, did they give you a public API for a memtable? Or a base class that you can modify?
There is a plugin system for memtable. You could insert your own.
Okay.
But from what I remember, you would need to actually include a lot of other stuff because there is a lot of dependencies there. But you can make the top level of memtable does have an interface.
So, Gabby, you may be able to do it without actually changing Roxdb then, if you can create your own version of the memtable.
If you can add our own version of memtable, and if it's possible that memtable will be, by doing discard or discardable memtable, that every time you push a reset or discard, then everything goes away. The version is updated on the on the write-ahead log, so they can be trimmed implicitly, and we could start again. So again, I'm hoping that this thing is doable, but in theory it sounds like it could be done. But I'm really not that familiar. Sorry, I'm not familiar at all with Roxdb code. But the theory makes sense to me.
Yeah, I think the theory makes sense, and like an insight, it's worth evaluating how much effort this is and how much benefit it could provide. Like some of the other things we talked about with respect to like the metadata are also pretty interesting because they would apply both to Blue Store and Crimson.
Yeah. So this thing I can only start doing Tuesday, and actually I really have to run.
We're way over the meeting.
Yeah, sorry.
Sorry to interrupt, but there was one thing I wanted to mention before we wrap things up, and that's regarding for like maybe next papers we can discuss. There is a storage systems and storage conference happening in 2 weeks. It was actually supposed to happen in Israel by IBM Research, but it's happening virtually. I'm going to link it here. It's obviously free registration, and there should be some pretty interesting talks there. So,
okay, can you send it by email? Because here I'm losing everything which is here. I'm going to lose.
Yes, I'll send it here for. Yes, I'll also send it on email for anyone. I'll send it to you, Gabby, and like the rest of the team. But it's also here in the chat if anyone's interested. Personally, I know a lot of the people organizing this event, so I looked at some of the accepted papers. So it should be pretty interesting. So if you guys are interested in that, that's happening on the 13th through the 14th of October.
Adding the Etherpad. And then maybe if people attend any presentations there, that are particularly interesting, we can add it as discussion topics for future meeting.
Yes, I plan to attend at least one of the days. So yeah, but I figured like if anyone else is interested, it seems like it's in pretty convenient times for both people from the US as well, or Europe, US, even China. So yeah.
Is this? I'm sorry. Did you say this was free registration?
Yes.
Okay.
I'll also paste the registration link because maybe it's a little bit hard to navigate in this website.
Guys, I really have to go. So have a nice weekend. I mean, Amnon, have a nice weekend. Everybody else.
Have a good day.
All right, see you.
Thanks. Bye.
Should
Bye.
we? See you, Gabby. Should we wrap this up, guys? We're way over.
Yeah, I think so.
Yeah.
Thanks
I
for
think
sharing
so.
that. That's interesting.
But as a last note, I thought about what Gabi was saying about skip lists. I think we do have some prefixes that we never actually iterate through them. So like deferred rights, maybe we could really drop a skip list memtable for that and just go for some hash that never thought about it before, but that seemed feasible.
Yeah, the same for the PG log. I mean, right now it's in the same. It's just using OMAP, so it's in the same column family as the OMAP data where we do potentially iterate. But we could move that out to a different column family.
Yep, that
Key
can
comparisons. Key comparisons to maintain ordering is one of the highest things I see in our wall clock profiles regarding the KV sync thread and write-ahead log. So that potentially could actually be a big win for us.
Yep, true. Until column families, we couldn't avoid it, but now we really can.
Mm-hmm. Mm-hmm. All right.
So thank you
Those are
guys.
good.
Have a good day.
Sounds good.
See everybody.
See you next week, everyone.
Today, later.